All right, in this last example, you get to show off to me how well you understood logs, because we're now needing to calculate the number of interest-bearing periods. So how many compounding periods are there? So that value of n, which is in our exponent, okay, and it's saying calculate the number of interest-bearing periods n, and hence means using that. How long will it take for $7,800 to amount to $10,000 at a rate of 8% per annum, compounded quarterly? Compounded, you're using your compound interest formula. Per annum, it's happening every year. Compounding quarterly. So let's put in our values. A is our final value, which is going to be 10,000. P will be 7,800, our principal value. Our number of compounding periods per annum, and it says compounded quarterly. That means every 3 months there are 4 compounding periods per annum. So that means that I'm going to be having R will be 8 over the 4, which is 2, and I'm looking for N. All right, let's put that in. So A equals P, 1 plus R over 100 to the power of N, and 10,000 is equal to 7,800 times 1 plus 2 over 100 to the power of N. And I can divide both sides by 7,800 so that I've got 1,000 over 7,800 is 1 plus 0.02 to the power of N. And I can now have 100 over 78 is going to be 1.02 to the power of N. And you can see that there's no ways that I can get these bases the same to be able to solve for N, so I can use logs. So remember, if we log both sides, and remember our third log law told me that I could bring my N to the front of my log. So that means I could have log of 100 over 78 equals N log 1.02. And I could divide both sides now by log 1.02 and get that N was log of 100 over 78 divided by log of 1.02. And when you put that into your calculator, you've got that N is approximately 12.55. Now there's some interpretation that happens here, because you can't have 12.55 compounding periods. The bank is very specific. They're saying that every quarter they will compound. So it is a whole number, and you're going to round it up to 13, because if you rounded it down to 12, you would not have got to your $10,000 yet. So you're going to say, therefore, N equals 13 compounding periods. All right. Now the next part of the question said, hence determine how long it would take for that to happen. Okay, so how do I work out how long, how many years I would take to do 13 compounding periods? Well, we know they're 4 per year, so our time taken would be our 13 over those 4 per year, and that would be 3.25 years. So therefore, it would take 3.25 years to reach $10,000.